Hello buddies, welcome back. This is Sidhu, Senior Lecturer in Chemistry from Sri Chaitanya Educational Institutions, Goshala. Today we are discussing about another important topic in NEET Chemistry syllabus, that is D and F block elements. This chapter is in class 12 NCERT, and as we know that it is part of inorganic chemistry and mainly theoretical chapter, we need to focus on NCERT and we need to be thorough with the NCERT line to line. Let us see some questions about D and F block elements. Let's go. Look at the first question. The first question is about electronic configuration. So look at the question. Choose the correct option having all the elements with the D10 electronic configuration from the following. So all have D10 electronic configuration. If you see that first one is palladium. As we know that palladium has some exceptional configuration. What is that? Palladium, we can write it as krypton 4D10 5s0. So it has obviously D10 configuration. But nickel, if you take it, it has 3D8 configuration. I don't need to write, just to, okay, it is a very famous element that we know it. Up to 30, all the students must be thorough with the electronic configurations. After 30, you must focus on exceptions like palladium. And iron has 3D6 configuration and chromium has 3D5 configuration. So nickel, iron, chromium do not have 3D10 configuration. Therefore, that is not the correct option. Let's go for second option. In second option, we have copper. Yes, copper has an exceptional configuration. What is that? Argon 3D10 4s1. Yes, it has D10 configuration. Zinc has, yes, it is having argon 3D10 4s2. It is having D10 configuration. And then cadmium also have 3D10 configuration. Krypton 4D10 5s2. And then silver also have 3D10 D10 configuration. Sorry, krypton 4D10 5s1. That means here silver, cadmium, zinc, copper. So all these elements do have D10 configuration. Therefore, that is the right option. Remaining all, if you see any other new element, we have nickel, no, D8, chromium we have already seen, everything we have seen. Cobalt, D7 configuration is there. Therefore, what is the right option with all have D10 configuration, that is copper, zinc, cadmium and silver. Suppose in the given problem, which will have the pseudo inert gas configuration. Pseudo inert gas configuration means D10 configuration. Okay, that is, we can include palladium also. So then, if you see these elements among that, here palladium has D10 configuration, pseudo inert gas configuration among the elements, not the ions. So if they ask ions, for example, copper plus 1 has pseudo inert gas configuration, zinc 2 plus has pseudo inert gas configuration D10, and cadmium 2 plus has pseudo inert gas configuration, and silver plus has pseudo inert gas configuration. Among the elements, which of the following has pseudo inert gas configuration means we have to consider only palladium as the answer. Let's go for the next question. The next question is about chromyl chloride test. That is very famous test and very famous reaction that is there in the laboratory manual also. What is chromyl chloride test? Here, NaCl react with concentrated H2SO4 in presence of potassium dichromate. Then we will get reddish fumes of B, which react with NaOH to give yellow solution C, B and C respectively. This is chromyl chloride test. Test for chloride ion or test for dichromate ion. What is this? Here, NaCl or chloride salt react with potassium dichromate K2Cr2O7 in presence of concentrated H2SO4. In presence of concentrated H2SO4, it forms a reddish brown vapors of chromyl chloride. What is chromyl chloride formula? CrO2Cl2. CrO2Cl2. We have the options like this. And then this is passed through NaOH. Then we are going to get an yellow solution of, what is that? Sodium chromate, Na2CrO4. This is the yellow color solution. This is the yellow color solution. There is continuation also for this. This is treated with lead nitrate. Then we'll get a chrome yellow red color, yellow color precipitate. yellow color precipitate. That also there for the continuation test. But in this problem, let's stop here. Here, when sodium chloride, like the chloride salts, react with H2SO4 with some amount of potassium dichromate, we will get reddish vapors of fumes of chromyl chloride. What is the formula? CrO2Cl2. And then when this solution is passed through, the NaOH will get sodium chromate, Na2CrO4. Therefore, what is the right option? Option 2. Let's go for the next question. Same, the chromyl chloride test only, but continuation, what it is mentioned, let us see. In chromyl chloride test, for conformation of chloride ion, an yellow solution is obtained. Just now we have seen that is Na2CrO4. This yellow solution, acidification of the solution and addition of amyl alcohol and 10% hydrogen peroxide leads an organic layer, formation of an organic layer, that is blue color layer, indicating the formation of chromium pentoxide. The oxidation state of chromium in that is. Here, they have already mentioned what is the product also. What is the product? Chromium pentoxide, CrO5. What is the oxidation state? Generally, if you go for this, chromium plus 5 oxygens, oxidation state is 0. Chromium, suppose oxygen is oxide form, 5 minus 2, so we will get like this. So, chromium oxidation state is plus 10 we are going to get. Do any element has the plus 10 oxidation state? It is very impossible. Here, the maximum possible oxidation state is plus 8 only. For chromium, what is the maximum possible oxidation state? Plus 6 only. It's group number 6. Therefore, plus 10 is wrong option, or plus 10 is wrong. Here plus 10 is there. Second option is wrong option. The actual answer or actual correct answer is, it has a special structure, beautiful structure is there. The chromium pentoxide, in fact it is called chromium peroxide. It has peroxy linkages. It has a beautiful structure of butterfly. It has butterfly structure. It has butterfly structure. Here 4 oxygens are in peroxide form and 1 oxygen is in oxide form. That means chromium oxidation state, 4 oxygens in peroxide form and 1 oxygen in oxide form. Total charge is 0 now. Chromium plus peroxide means what is the oxidation state of oxygen minus 1 and oxygen minus 2 is equal to 0. Then chromium minus 6 is equal to 0. So chromium oxidation state will become actually plus 6. So what is the right answer? Plus 6. Plus 6. The answer 4th option. So chromium peroxide, what is the oxidation state of chromium? Plus 6. So plus 10 is wrong option. Let's go for the next question. The next question is about statements mentioned in NCERT about oxidation power and reduction power. Let's see. It is a type of assertion reason question. Given below are 2 statements. One is labeled as assertion A and another one is labeled as reason R. What is the assertion? In aqueous solutions, chromium 2 plus is reducing while Mn3 plus is oxidizing in nature. The reason is extra stability of half-filled electronic configurations is observed than incompletely filled electronic configuration. So what is this? Let us see. In fact, chromium 2 plus has 3d4 configuration. Manganese 3 plus also has 3d4 configuration. Both have 3d4 configuration. But still, chromium 2 plus act as reducing agent, Mn3 plus act as oxidizing agent. Why this is happening? Because the chromium 2 plus upon losing electron convert into chromium 3 plus. After losing electron, it convert into chromium 3 plus. This chromium 3 plus has a configuration of 3d3. In aqueous solution, water is surrounded with the ion in octahedral geometry. Then splitting of d orbitals takes place. This is called crystal field splitting. We know that the crystal field splitting in octahedral geometry is like this. 2 orbitals raise their energy and 3 orbitals decrease their energy. What if this set is called T2G set? What if this set is called TG set? In T2G, if 3 electrons are there, what is this configuration? Half-filled configuration. So, half-filled configuration in T2G set, which is more stable configuration. This is T2G3 and Eg 0. This is more stable configuration. That means in aqueous solution, chromium 3 plus is stable as T2G3 is stable configuration. That means chromium 2 plus losing electron and convert into chromium 3 plus. Therefore, chromium 2 plus act as reducing agent. What about Mn3 plus case? In case of Mn3 plus, after gaining an electron, I am writing here, Mn3 plus after gaining an electron, Mn3 plus after gaining an electron, it convert into Mn2 plus. Yes. Mn3 plus has D4 configuration. What about Mn2 plus? Mn2 plus have 3D5 configuration. 3D5 means again half-filled orbitals we are going to get. That means we know that D5 configuration, which is more stable. D5 configuration which is more stable, half-filled orbitals. So, what is the reason? Once again, let us see the reason. The extra stability of half-filled electronic configuration, either it is in T2G set of chromium case or total D5 electrons in case of manganese. The stability is more. Therefore, Mn3 plus gains electron and acts as oxidizing agent. Cr2 plus loses electron and acting as reducing agent despite of having same configuration. So, why can't we apply the same here in this case also? Like this we can apply. Here also half-filled in case of upper set and half-filled in case of lower set. That's why Mn2 plus is more stable. Both have half-filled, either T2G set as well as EG set. Why not in case of chromium? Because generally chromium plus 1 state we don't see. It is highly unstable state. Chromium more stable state is plus 3 in fact, rather plus 6. Therefore, chromium 2 plus in aqueous solution act as reducing agent. Manganese 3 plus in aqueous solution act as oxidizing agent. That's all. So, what is the right option? If you see that here, aqueous solutions of chromium 2 plus reducing and Mn3 plus is oxidizing, right statement. The reason is extra stability of half-filled electronic configuration in T2G set in case of chromium and total D5 configuration, T2G as well as EG set in case of manganese. Okay, increases the stability. Reason is correct option. Also the correct explanation. Therefore, what is the right answer? First option. Both assertion, look at this, this is interesting. First option they have mentioned is not the correct explanation. It is a twist. Be careful. So, both A and assertion and reason are true, but R is not the correct explanation. If you are going in a hurry mode just like me just now, it's a practical experience now we are getting. See, what is the right option? Both option A, assertion A and reason R are correct, are true, and R is the correct explanation. What is the right option? Option 3, not option 1. So, be careful. Let's go for the next question. The transition metal having highest third ionization enthalpy. Generally, IE1 and IE2 we expect in main group elements. The trends we have seen in periodic table lesson. Now, in case of transition elements, we can expect the trends for IE1, IE2 and IE3 also. So, here third ionization enthalpy is more. What is the meaning of it? It is difficult to remove third electron. That means M2 plus is stable. Please keep this in mind. If first ionization energy itself is high means neutral atom is more stable. IE1 is highest or high means neutral atom is stable. IE2 is high means positive, mono positive cation. M plus is stable. IE3 is high means what is stable? M2 plus or di-positive cation is stable. Now let us see the di-positive cations here. This is iron 2 plus, this is chromium 2 plus, this is vanadium 2 plus and this is manganese 2 plus. What is manganese 2 plus? 3D5. Vanadium 2 plus we are going to get 3D3 and chromium 2 plus we are going to get 3D4. Iron 2 plus we are going to get 3D6. So what is the more stable one? Obviously Mn2 plus. So which will have the highest third ionization enthalpy? Manganese. Right answer. Fourth option is the right answer. Let's go for the next. Which statements among the following are correct? This is very interesting question about lanthanides. Well known question. Cerium plus 3 is an oxidizing agent and colorless. Actually, if you see, generally what is the more stable oxidation state of lanthanides? The more stable oxidation state of lanthanides is plus 3. Then cerium can also show +4 oxidation state. What is the cerium configuration? First, if you see the cerium configuration, we are going to get it as, okay, xenon 6s2 4f1 5d1. This is the configuration for cerium. Cerium +4 means it has xenon configuration with no d electrons, no f electrons. What about cerium +3? Xenon 4f1. So cerium +3 has 1 f electron. So here it is colorless mentioned, which is actually wrong. Cerium +3 is colored. It has 1 unpaired electron. Next one, it is oxidizing agent. Please keep this in mind. In case of lanthanides, +3 is more stable state. If +4 is there, that means if +4 is there, it tends to gain electron and convert into +3. That means cerium +4 gains electron and convert into +3 means cerium +4 is oxidizing agent but not cerium +3. So what is oxidizing agent here? Cerium +4 is the oxidizing agent, also colorless because it does not have any f electrons. Therefore, cerium +3 they have mentioned, which is incorrect. The next one is lutetium 3+ is colorless. What is lutetium electronic configuration? So this seems the right statement. 4f14 5d1 6s2. This is the last lanthanide. Here lutetium 3+ if you go for, it has xenon 4f14. It does not have any unpaired electron. It is colorless. So option 2 is right. Actinides exhibit higher number of oxidation states than lanthanides. That is also right statement. Lanthanides has common oxidation state +3 and some elements rarely shows +4 like cerium and +2 like europium. But actinides, the energy gap between 5f orbitals and 6d orbitals and 7s orbitals, especially 5f and 7s orbitals is less. Therefore, they show the variable oxidation states. So, this is right statements. Actinides exhibit higher number of oxidation states than lanthanides, right only. All 3D elements give hydrogen with HCl. As we know that some of them are inactive elements, especially in 3D. What is the inactive element? Are less electropositive element, that is copper. Inactive element. Copper having positive SRP value, it cannot displace hydrogen from the acids or water. Along that copper, some other elements also like mercury, platinum, gold, silver. These elements cannot liberate hydrogen. Here they have mentioned all 3D elements give hydrogen with 1 molar HCl, which is actually a wrong statement. So what are right statements they have? Okay, lutetium 3+ is colorless. Actinides exhibit higher oxidation states than lanthanides. So 2 and 3 are the right statement. That means what is correct option? Option A. Let's go for the next question. Next question is clearly about NCERT lines. You must have command on NCERT lines. Then only you are able to do this question. I am telling NCERT lines, especially for inorganic chemistry, they are very important. You need to learn every point if you want to get 180 out of 180 in NEET chemistry. Let's go for the question. Choose the correct statements from the following. Mn2O7 is actually an oil at room temperature. This is also NCERT statement. Mn2O7 is a covalent green oil. That is the NCERT line. It is covalent, also green color oil, explosive, highly acidic substance. So this is right statement. Next, V2O4 reacts with acid to give VO2 plus. Let's see. There is a twist in this problem. B, maybe right or wrong. I am not sure. Let us see. After completing, I will tell. Chromium oxide is a basic oxide, right? NCERT line. V2O5 actually amphoteric. So it reacts with acid as well as the bases, but they are telling it does not react with the acid. That means we are 100% sure that A and C are correct and D is incorrect. They are asking correct answer from the following options. So A and C, where is A and C? Either A and C is there here. B is incorrect, right? So sorry, not B, which is incorrect. D is incorrect. So D is incorrect means we can eliminate this option. And A and C are correct. Okay. A and C are correct. B, C only also we can eliminate. Okay, na? That means we have two options. and the answer depends on option, that is B. V2O4 react with acid to give VO2 plus. VO2 plus, sorry. That is actually wrong. Sir, how can we do that? How can we memorize? How can we do that? You need to do with some logic. What is V2O4 actually? What is the oxidation state of this vanadium plus 4? Here, what is the oxidation state of vanadium mentioned? VO2 2 plus. Vanadium oxidation state becomes plus 6. Do vanadium exist plus 6 state? No. Wrong actually. Here V2O4, when it in acidic medium, it convert into VO2 plus, but not VO2 2 plus. That is wrong. So, pinpoint information. You must learn every detail in the NCERT. But some logic is obviously there when the question is framed by the examiner. They don't give blunt statements. There is some logic. So, therefore, B is incorrect. Therefore, what is right option? A and C only. Mn2O7 is a covalent green oil. Right statement, and CRO, chromium oxide monoxide, is a basic oxide. Let's go for the next question. Oxidation state of manganese in the compound formed by alkaline oxidative fusion of MnO2 by KOH is. This is about the preparation of potassium permanganate. So, direct line from NCERT. So, the manganese MnO2, the manganese compound pyrolusite, is oxidatively digested or fused with KOH or K2CO3. What is the product we will get? K2MnO4. What is the manganate? This is called potassium manganate. What is this? Potassium manganate. K2MnO4. Potassium manganate. Potassium manganate. What is the manganese oxidation state? Plus 6. What is the color of this? Green. What is the color of this? Green. You need to know that. The color of this is green. So, when MnO2, the pyrolusite, is oxidatively digested with KOH, we are going to get K2MnO4. This K2MnO4 disproportionate to give a KMnO4. Those things are continuation for the preparation of KMnO4. Let's go for the next question. The next question is about again lanthanides, and let's see that lanthanides and other consequences, properties. Consider the following statements. Lanthanum hydroxide is least basic among the hydroxides of lanthanides. Let's see this statement. We know that lanthanum hydroxides are hydroxides of lanthanides or oxides of lanthanides are basic in nature. Their basic strength directly proportional to size. This is very important. Charge is common for all of them. Bigger the size, higher the basic strength. Now, if you see that, what is the size? If you see, lanthanum is the biggest one. Lanthanum 3 plus is the biggest one. And gradually the size decreases. That means basic strength decreases gradually up to lutetium. So, what is the most basic one? Lanthanum trioxide or lanthanum hydroxide. What is the least basic one? Lutetium oxide, lutetium trioxide or lutetium hydroxide. That means here lanthanum hydroxide, it should be most basic. So, but here they have mentioned it is least basic, therefore that is incorrect statement. Let's go for next. Zirconium and hafnium possess almost the same atomic radii. Same ionic radii. You know, if you remember. Okay. There is lanthanide contraction, extension of lanthanide contraction. So, due to this, almost zirconium and hafnium possess the similar size. Atomic radii, zirconium is around, 160 picometers and hafnium is around 159 picometers. Right statement. Let us see, but they have given ionic radii. Let us go for the next statement. Cerium plus 4 can act as oxidizing agent. This is right only. I have already discussed. Cerium plus 4. All lanthanides with plus 4 oxidation state tend to gain 1 electron, act as the oxidizing agent. So, 3 is correct. They are telling about true statements only. We are 100% sure that 3 is correct, 1 is incorrect. 3 is correct and 1 is incorrect. So, let's go for 1 and 3 wrong option, and 2 and 3 yes it is there, and only 2 wrong option, only 1 is also wrong option. So, actually if you go for this, zirconium hafnium possess the similar atomic radii. Ionic radii mentioned, atomic radii is actually right way. Okay, right framing, right data also we have in NCERT. Ionic radii we don't have the data, but however almost similar. Okay, radii if you take 2 and 3 are the correct statements. So option C is the right option. Let's go for next question. The next question is about again potassium dichromate properties. Identify the correct statements from the below. Let us see statement A. Chromate ion has square planar structure. What is chromate ion? CrO4 minus. What is its structure? Its structure is tetrahedral. Its structure is tetrahedral. CrO4 2 minus. Sorry. Unfortunately, they have mentioned a square planar, which is incorrect. Let's go for option B. Dichromates are generally prepared from chromates. How? We know that dichromates are prepared from the chromates by acidifying the solution. If you add an acid to that chromate solution, then it will convert into dichromate. If you add a base to the dichromate, it will convert into chromate. So, dichromates are generally prepared from chromates. Therefore, that is the right statement. Next, the green manganate ion is diamagnetic. What is manganate ion? MnO4 minus, MnO4 2 minus. What is its configuration? 3D1. What is manganese oxidation state? Plus 6. It has one unpaired electron. Number of unpaired electrons is 1. One unpaired electron is there. If one unpaired electron is there, how can it is a diamagnetic substance? It is a paramagnetic substance. The next one. The dark green colored K2MnO4 disproportionate in neutral or acidic medium to give permanganate. That is also right statement. It is mentioned in NCERT. K2MnO4 undergoes disproportionation in acidic or neutral medium to give KMnO4 and MnO2. So here, this is a preparation method of potassium permanganate from manganate. So if you make the solution little acidic or neutral, it undergoes disproportionation. Now go for statement E. With increasing oxidation number of transition metal, ionic character of oxides decreases. With increasing oxidation number of transition metals, as we know that covalent character directly proportional to oxidation number. Charge. Higher the charge, higher the covalent character, lower the ionic character. So here increasing oxidation number decreases the ionic character, right statement. Increasing oxidation number increases covalent character, decreases the ionic character. So therefore, what we have got is here D is right, E is right and B is also right. A is incorrect, C is incorrect and then B, D, E are correct. Therefore, what is the right option? Option 3, B, D, E are correct. Are you clear with this? Let's go for the next question. This is about lanthanides and lanthanides only. Now, which of the following act as strong reducing agent? As we discussed in case of oxidation power, here lanthanides, they have +4 state. They gain electron and convert into M3, +3 state. Therefore, M+4 is oxidizing agent. M+4 is oxidizing agent. If they have +2 state, it loses electron and convert into M3 plus. Therefore, M2 plus is reducing agent. So, what is the right answer here? What has +2 state? Europium. Do europium exist as +2? Yes. Due to what is europium electronic configuration actually? Its electronic configuration is xenon 4f7 and 6s2. It shows +2 state, one of the elements that show +2 state, xenon 4f7. However, the +2 state is unstable for lanthanides. So, one more electron will be lost and then europium 2 plus is converted into europium 3 plus. Therefore, europium 2 plus act as the reducing agent. Let's go for the next question. They have given some statements again. Which statement is incorrect with reference to the inner transition elements? This is also about lanthanides and actinides. Option A. The oxides of lanthanides are basic. Just we have seen this already. Basic strength also we have seen the trend. So A is correct. Option B. The promethium is radioactive element among the actinoids. So be careful. Promethium is radioactive. You see the half of the statement and then blindly go for the answer. Wrong. Promethium is radioactive, right only. But next, it is an actinide. Unfortunately, promethium is not actinide. It is lanthanide. The students are in a hurry-burry mode such that promethium is radioactive. Done. Go for the right option. Go for the choice. Promethium is radioactive. Half of the statement is correct. But it is not actinide. It is lanthanide. It is like Aswadhama Hataha Kunjaraha. So it is in Mahabharata, you know, right? So the Yudhishthira says Aswadhama Hataha, but it should not lie. Therefore, in the suffix he had Kunjaraha with low voice. So be careful. First half you study, okay, you read and then go for the option. That is wrong. So promethium is radioactive, but that is not an actinide. It is lanthanide. This is incorrect. Go for option C. The values of ionization enthalpy of actinides is less than that of lanthanides. Right only, because actinides are bigger in size than lanthanides. So down the group ionization enthalpy decreases. Therefore, actinides ionization enthalpy is less than the lanthanides. Right only. C. Let's go for D. Only in the electronic configuration of lanthanides like cerium, gadolinium, lutetium, the electrons are filled in 5d orbitals. Yes. In case of cerium, we observe 5d1. In case of gadolinium, we observe the 5d1. If you see the electronic configurations, in case of cerium, what is its electronic configuration? Cerium, it is xenon, 4f1, 5d1, 6s2. And then if you go for gadolinium again, the D appears. Xenon, why? Because half filled electronic configuration is more stable. We'll get like this. And then finally lutetium. What is that? Xenon, 4f14, 5d1 and 6s2. Only in case of cerium, gadolinium and lutetium, we observe the D1 configuration. Let's go for next. So here D is correct. That means what is incorrect statement? Option B. Let's go for next question. The diamagnetic lanthanide ions are. So here magnetic properties depends on number of unpaired electrons. Diamagnetic means the number of unpaired electrons should be 0. Number of unpaired electrons should be 0. Here number of unpaired electrons is 0 means we need to take certain ions. Suppose if you go for this, you see this option. Lanthanum 3 plus, what is its configuration? Xenon, full filled orbitals. Cerium 4 plus, what is its configuration? Xenon, full filled orbitals. So lanthanum 3 plus and cerium 4 plus have full filled orbitals. The number of unpaired electrons is 0 in these. Therefore, they are diamagnetic in nature. In case of neodymium, it is in fact paramagnetic with unpaired electrons are there. Cerium, okay. So this is okay na, paramagnetic. Therefore, that is not a correct option. Lutetium, okay, does not have any unpaired electron, but europium has unpaired electrons. This is also incorrect. And neodymium, europium, that is also incorrect. What is the correct option? Lanthanum 3 plus and cerium 4 plus. Let's go for the next question. The next question again we are coming back to the transition elements and the statements in NCERT. The incorrect statements among A to C are, they have given. Tungsten 6 is more stable than chromium 6. This statement is mentioned in NCERT. If you go for main group elements, especially p block elements, down the group, higher oxidation states are unstable due to inert pair effect. But in case of transition elements, we don't observe the inert pair effect. Here, tungsten 6 is more stable than chromium 6 due to strong metallic bond, metal bond. So that is right statement from the NCERT directly. In the presence of HCl, permanganate titration provides satisfactory result. There is a problem. This is a laboratory manual question also. When you take KMnO4 for the titrations, what is the medium that we need to use, especially acidic medium? It is a powerful oxidizing agent in acidic medium. To provide the acidic medium, can we use HCl? No. What is the best acid we can use there? H2SO4. What happens when you use HCl? Here KMnO4 oxidizes HCl to give chlorine. So therefore the medium itself reacts with the reagent. Therefore we don't get the satisfactory results, which is actually incorrect statement. The next option C. Some lanthanide oxides can be used as phosphors. This is right statement only. Uses of the lanthanides. So A and C are correct. Therefore, wait a minute. Some lanthanide oxides. They have asked incorrect statement. Sorry. They have asked incorrect statement among the following A to C. Incorrect statement is here option B. So what is that? Option B only. Let's go for next question. The next question is about again lanthanides and actinides, F block. More number of oxidation states exhibited by the actinides than those by the lanthanides. The main reason is, we have discussed also, I have mentioned. Here lanthanides have fixed oxidation states mainly, that is +3. But in case of actinides, they show variable oxidation states. Why they show variable oxidation states in case of actinides? In case of actinides, here the orbitals are 5f and 6d and 7s. The energy gap between these orbitals, as n value increases, energy gap decreases. Since the energy gap is small between these orbitals, we can remove s electron, d electron as well as f electrons. Therefore, the lesser energy difference between 5f, 6d and 4, than between 4f and 5d. Due to the small energy difference, the actinides shows the variable oxidation states compared to the lanthanides. This is the option D is the right statement. That's all. Thank you. Thank you very much.